Sort of quick recap of what we talked about yesterday was basically this first example, right? The situation where we're looking at something where we've got kind of a rule in place for how things work, for how two things are related, right? The big idea that we're building up to is a function, which is a way to describe two things. You know, often it's going to be like numbers, but two things and how they're related to each other and how they depend on one another, right? So the first example, we looked at kind of having this rule in place where what happens is you work and in exchange for your work, you get paid $12 per hour. So we talked about, if you know how many hours that you work, you figure out how much you should get paid by multiplying, right? Because multiplication is basically just repeated addition, right? So if I work 3 hours, that's 12 and 12 and 12, or 12 times 3, right? And we wrote a formula that would do that for us, right? I don't remember what labels we used in here because, everybody kind of picked their own, but something like P, maybe the amount on your paycheck is 12 times T, the number of hours that you worked, right? Amount on your paycheck, number of hours worked. Okay, and again, especially in like applications, but always, I'm kind of making a big deal about it now, but it's important, I think, to keep in mind, sort of keep like front of your mind, what the two things actually are that we're relating together. This formula shows us how they're related, right? This one's 12 times that one. And then we did a couple things with it, right? We figured out, okay, if you worked 25 hours, part C there in that first example, if you work 25 hours, how do you figure out how much you should get paid? And what? Multiply, yeah. Replace the T, because that's number of hours worked, with the value that you want, right? 25 hours. And then basically follow the instructions that gives you, right? It says, okay, well, what you should do is take 12 and 25 and multiply them together, and that gives you 300. Right? Okay, that's the like 90-second version of what we did yesterday. And then we did one other thing to sort of extend on that, right? I said something like, and I wish I hadn't erased it now, but how long would you have to work to earn, I don't remember what we used yesterday because I was making it up as we went, but to earn $240, for example, right? How is this different? It's kind of samey, but kind of different too, right? What's the difference? Yeah, we're looking for the number of hours, right? So instead of giving you T and asking for P, P, I'm giving you P and asking for T instead, right? So setting this up, again, the idea is the same in that we're taking one of those variables and replacing it with something and then trying to find the other thing, right? It's just that we've swapped which one we know and which one we don't, right? Now, the other difference is that here, what I need to do next isn't spelled out for me quite as clearly, right? The other one, once I did the replacement, it looked like that, and everything's right there in front of you, right? It's take these two numbers and multiply them, right? So we took this kind of high-level idea, and by setting this thing up, we turned it into a like fourth grade arithmetic problem, right? Now it's just take these two things and multiply them together, right? The directions are kind of right there. Here we're trying to solve instead, right? So we've replaced the thing, but now the instructions, like what to do next, isn't spelled out quite as clearly. We've got to think about what to do next, right? So what should we do next? Divide, right? We're trying to get T, the unknown thing, by itself. That means we've got to move the 12 away from it. The way you move the 12 away is by dividing, because what's there already is multiplication. You want to do the opposite. The opposite of multiplying is dividing, right? And if you do it to one side, you got to do it to both to sort of keep things in balance and to retain that equality, right? That equation or the equal sign that was there. All right, so 12t divided by 12 is just 1t, right? We normally don't even write the 1. We just say it's t. Okay, cool. So that's the thing I'm looking for. And on the left, 240 divided by 12 is 20. Right? Okay, so to answer the question, you would need to work 20 hours in order to earn $240, right? Everybody cool with that? Okay. We feel comfortable with this. This isn't like totally outside the box, hopefully. Okay, great. Okay, so this thing that we've just been looking at, this relationship, let me get some of this stuff out of here. So we don't have quite as much going on. This thing that we've been looking at is an example of a function, right? This equation formula version of this, that's one way of representing a function, right? Another way of representing it is just describing in words like we started with, right? You get paid 12 bucks an hour for working, right? That kind of tells me how the relationship works. This is the sort of math symbolic way of looking at how that relationship works. If we were to, sort of list out some values, we could kind of look at it numerically, right? If I work 1 hour, I get paid $12. If I work 2 hours, I get paid $24, and so on. You could even get more granular with that. Like if I work 1.5, then I get, 12 and a half of 12, so 18, right? You get more granular with it and look at a numerical representation like that. We can look at it graphically. We'll get the graphs in a little bit here, but that's a functional relationship. Now, part of that, let me just write some kind of thoughts on functions. A way of describing how two things are related. And maybe, wherever you write that down, leave yourself some space or something, because we're going to add some things to that. But a way of describing how two things are related. Okay, so again, working from this like same example, what are the two things? How much you worked, right? Which is, we measure in hours, and how much you got paid, which we measure in dollars, right? Okay, so these are our two sort of quantities, right? So think of these as sets. If you want, a set is just a collection of things, right? These three things, these two remotes and my keys, this is a set, right? It's just a collection of things. It's a very loose term. There's no like extra conditions on it or anything. Number of hours worked, dollar amount on paycheck. Okay, so those are our two sets here, and what the rule that's in place, that you take this one and you multiply it by 12 and you get the thing it goes with over here, that's the function that's involved, right? Is how you take a thing over here and pair it up with the thing over there, right? So for example, if I work 5 hours here, I get paid 12 times 5, $60 there, right? Those two things match up. And there's a whole bunch of, other like arrows. I'm just drawing one as an example, right? Now, in order to be a function, there's also one more kind of condition on this that we need. And the way we handled this question kind of gets at what that condition is. If you want to earn $240, you need to work 20 hours, right? So what if, and again, assuming like your pay doesn't change, you didn't get a raise or an anti-raise or whatever, pay rate stays the same, right? If the next week you work 20 hours, how much should you get paid? $240 again, right? What if the next week you work 20 hours and your boss only pays you $200? What are you going to do? Send a sternly worded email, right? Or like have a talk with somebody, because something hasn't gone the way it should, right? Okay, so being a function means not only you take these two things and sort of pair them up, right? And like relate them to each other, but also you do it in such a way that if you work the same number of hours, you get the same amount of pay, right? That you don't work 20 hours one week and get $240, work 20 hours the next week and get $100 or something, right? So you want to sort of preserve this idea that if the, we'll think of it as like the input, if the thing that you do, the number of hours that you work stays the same, for a given value there, the amount that you get paid should always kind of sort of match that or like go with that, right? That shouldn't change, again, unless you get a raise or, you know, the rule changes somehow, right? But as long as things work the same, then the amount that you work should always, you know, result in getting paid the same amount. So we want a particular thing here to always go to the same thing here. It would be a problem if I worked 5 hours one week and got $60 and then worked 5 hours the next week and got $50. That would not be good, right? This thing going to two things is a problem. This is a problem. Okay, so another quick example to think about. A vending machine. I draw in the like old timey ones, but okay. So a vending machine, right? You got the different, you know, I like the like big buttons that have the picture of the thing here, right? You got the big buttons. What you do is you put some money in, you press the button, it gives you the thing, right? Okay, so take a minute with your group, talk about like how that should work and what on earth it has to do with what we've just been talking about, right? See if you can get your head around that idea. Right? No. Okay, so somebody tell me how it works. How do you interact with a machine like this? Okay, you put some money in, right? I put in $1. What else? Do it. Okay, and then I click a button. And then what? The bottle's harder to draw. Okay, so ideally, if everything's doing what it should be doing, I put in some money, I push a button, the machine gives me the thing that matches the button I push, right? Okay. I don't really get to like control the money part, right? So let's kind of take that part out of it. Like, let's just think about the place where I get to like make a decision, right? That's putting the or giving the choice of the button that I want, right? Okay, so this is the thing I do, right? This is my input. Choosing a drink. And if everything's working the way it should, then the thing that happens is the output from the machine, the thing it does is dispensing or vending or spitting out the matching drink, right? That part's important. How can this go wrong? you get the wrong drink, you don't get anything at all. You get, it starts just like dropping an entire 30-pack of Cokes at you. That would, maybe not be a problem that you're like that upset about, but it's still not working the way it should, right? Okay. So ways that this can go wrong are all related to the thing that the machine does not matching what you asked it to do, right? Okay, you push a button, what it should do is, give you a Coke if you chose a Coke, right? If you push the Coke button and it gives you nothing, or sometimes it gives you a Coke and sometimes it gives you nothing, or sometimes it gives you a, God forbid, a Diet Coke, then like the machine's not working the way it should, right? Okay, I'm gonna make a bad pun now. It's not functioning correctly, right? Because what a function should do is that when you push a button, it does the one thing that it's supposed to do, right? Okay, so that's the same as, our example about like how much you get paid. Your input is how much you work. The output is how much you get paid. Those things, if you work a certain amount, you should get paid, well, 12 times that amount, right? In that example, right? Not 12 times that amount sometimes and a different amount other times and not at all some other times. They should match, right? Okay, so a function is a way of describing how two things are related, where we think of one thing depending on the other. Where a, let's say this, where each input always pairs with, let's say that, one particular output. Okay, so let's just real quick kind of look at an example that's maybe a little bit more abstract. Say this is the set of input stuff and this is the set of output stuff. And let's say what our function does is this. So again, the function is the thing that's like relating them together, right? And there are a lot of, specific ways that can go, but it's the thing that's pairing these things up. So what this function does is it sends or maps or pairs 1 with A and 2 with A and 3 with B, right? Okay, and it doesn't matter, 1, 2, 3, A, B, like none of what those things are matter. It's just how they're paired together, right? That's the part that we're looking at. So these are button presses and the drinks it gives you, or how much you work and how much you get paid, whatever. Is that a function? Why? Okay, so there are two things going to the same place, right? One matches with A, 2 also matches with A. What would that be like in the vending machine example? What are these? Choices. These are buttons. What are those? Drinks, right? Those are the things that come out. You can have 2 buttons that do the same thing, right? What we don't want is one button that does 2 things. Does that make sense? You see the difference? Okay, so this is 2 buttons that do the same thing. Is that okay? Because those buttons each do the same thing every time, right? There's a Coke button, there's another Coke button, there's a who cares something else button, right? But all of them do the same thing every time, right? That's fine. That's good. That's what we want, right? That is a function. Okay, so yes, this one works, right? This is a function. What if instead it looks like that? What did I change? What does the top button on the machine do now? Sometimes it gives you a Coke, sometimes it gives you a Diet Coke, right? So now we've got two things, sort of tied to the same place, right? Which is what you noticed before. The difference is though, it's one button that does two things. That's a problem, right? This is not a function, and that's why. One button doing two different things. Does everybody see the difference? Okay. It's, it's a subtle thing. I get that. I think, for a while, like thinking about it in those terms, the button and what it does might be a helpful thing to do. But because, just sort of looking at the picture, like, yeah, you're looking for, two things kind of coming from the same place, but there's a difference in what goes on here. Again, three buttons, but they each do their job every time, versus what goes on here, three buttons, but one of them does different things at different times, right? That's a problem. That's what we want to avoid. Okay, so with the groups, sorry, a little bit of terminology stuff real quick. So a function we've been talking about, a function is a special kind of relation, which is kind of more general. A relation is anything that pairs two things together. So like both of the examples that we just looked at, the working vending machine or the broken vending machine, they're all relations, right? A function is a special kind because you get that restriction where you want each button to do one thing, right? The set of input values for a function we usually call the domain. And the set of output values we usually call the range. Okay, so when we talk about domain and range, the vending machine thing, the domain is the buttons or drinks. Buttons. And the range is the drinks. In the how much you get paid example, the domain is how much you worked. The range is how much you got paid, right? Okay. All right, so with your groups, take a look at that second example there. Suppose you have a list of everyone in the room along with their height, right? So you got a list that's like, Dr. Thomas is 6 feet tall. Haley is 5 feet tall, etc. Right? All 26 of us, 27 of us, whatever. Name, height. Can you find a function that relates those two sets of information? So any way that you list them out together is a relation, right? Can you find a function that relates them together? And, why does it matter? Why do we need to be careful? And then, what are the domain and range of that function, right? So the domain or the range, the two sets are going to be a list of names and a list of heights, right? You're trying to decide which one needs to be which, and does it matter which way we pair them up? Okay, so take a few minutes to talk about that. I will, float around. Oh, no. Like, Will? Okay, yeah, okay, all right. No, Will. All right. So, list of names, list of heights. There are two ways that we can pair these things up, right? Either we go this way, or we go this way. Does it matter? There are, I think, 27 of us in the room. Does it matter which way we pair those together? Why? Can't put somebody else's height on. Say again. There could be two people, and there almost certainly are with this many people in the room, two people that are the same height, right? Are there two people with the same name? No, right? Even, I mean, there are a couple people with the same like first name, but like list first and last, or you know, whatever, right? They're different people, right? They're distinct. So there are no things here that show up more than once. There are almost certainly things here that show up more than once, right? Okay, so if we try to pair these up, like, is anyone else either 6 or 5 feet tall? Okay, so even if we just have those 3 people, right? I don't really need to list that one twice, right? So if I'm going to match these up, I could do it like that. Is that a function? If I'm thinking of this as the like first thing or the input or the domain, and this is the second thing or the output or the range, that's a function, right? This is 2 buttons that do the same thing, but that's okay. If we tried to do it the other way though, now we've got a problem. Because when I hit the, well, this is going to get weird, when I hit the 5 foot tall person button on the human vending machine, sometimes it's going to spit out Haley, other times Mary, right? And that's a problem. That doesn't work the way we want it to, probably for a lot of reasons. But that doesn't work. That doesn't preserve this like function relationship we've been talking about, right? So we need to pair these up this way by matching a person's name with their height and thinking of that as sort of the like input being the name and the height being the output. So the domain, we want to be all of the names. We would just list them, right? Because there are 27 or something. Basically, the idea is if there are few enough that you can just write them down, then you just write them down, right? If you can make it a list, like my roster sheet here, right? I could take this list and I could go around the room and ask everybody how tall you are and write down your height next to it, and we would have it, right? The range would be a list of heights. If we're not going to list anything twice, like repeat things, which one of those is smaller? The range. Yeah, the list of the heights, right? because there are going to be fewer of those because some of them are going to show up twice. There won't be any repeats in the list of names because again, I'm going to use, first and last and ID number or whatever I need to like make sure that I can tell each person apart, right? No repeats there, but there would be repeats in the height probably. Does that make sense? Does everybody see why it doesn't work the other way? Okay, cool. Just a little bit of like notation stuff so so it doesn't seem like totally foreign when you see it in the homework. Usually the way that we write a set is with a set of curly braces like that. That just means all the stuff between these braces goes together. So if I was going to actually write out the domain for this set, I would just use a set of curly braces and I would start writing names down and list everybody out, right? Okay. Okay, cool. So that's, again, kind of gives you a picture of like what a function is and how we preserve that relationship. Now, the sort of more math classy version of that is how we write things down using function notation. Kind of our default, variables to use are X and Y. If they're near it doesn't matter why, but X and Y, those are kind of our default like things to use, right? And what we'll typically do is talk about how X and Y depend on each other, right? And the usual thing is to think of this as being the input value, right? So that's like the button that you press. And the function then is the output, the thing that gets returned. Now, the way that you read this notation, y equals, and you can put is in place of equals if you wanted, right? Because equals means that they're the same. F of X. So that's the way you read that. Y equals F of X. F is just the name of the function. We just do that so that we can, sort of write them down and do things in a little more, a little less clunky way than having to like write out the full rule for the thing every time. The parentheses here mean sort of a different thing than they do in other places, right? Like often we use parentheses to mean like, this stuff gets multiplied by this thing next to it or something like that. These parentheses, function parentheses mean of. So what this says is that there's a function called f. We use f because the word function starts with an f, and we're not really that creative about naming things sometimes. So f, so it could be a g or an h or anything else, right? That part's not important, it's just the name. F of X means that F is a function of X, means that the way I'm going to write the rule down is I'm going to use X as the symbol that I'm using, right? So like when we wrote our formula down for the pay thing, what did we write? P equals 12T or something, right? So P is a function of T, right? Because I'm using T to write down the like rule part of it, right? The formula part. Okay, so again, the thing in here, the input or argument kind of means the same thing. That's just the symbol that you're using to write it down. So that's the input, that's how many hours you worked, or the button that you chose to press, or whatever. That's what you're feeding into the function. It does its thing, right? You apply whatever the rule is to it, you do the thing, you figure out what goes with it. That's the Y value or the output that it gives you back. So take a look at example number 3 there on the back. We're defining, so when I say suppose that f of x equals, that means I'm defining a function that we're going to call f, And we're pretty much gonna we're only gonna hold on to that for, one problem at a time, right? It's F. This is what F is in the context of example number 3. We might move on and problem number 4 is gonna have a different function that's also called F. Does that make sense? All right, we're just using it as like a placeholder so that we can talk about it. So suppose that f of x is equal to 2x plus 3. Okay, so this is a function called f whose argument or whose input is x. So the symbol that we're using is x to write it down. And what it's defined by is 2x plus 3. So if I give you an x value, what do you do to it to figure out the y, the output that goes with it? You multiply it by 2, and then you add 3, right? So this 2x plus 3, the part that looks like a formula, if you want, that's the rule for how this function turns x's into y's, right? Okay, cool. So with your groups then, we got just a couple minutes left, but think about, we basically just answered part A, like how this changes an input, an x value into an output, a function value. That's that, you multiply by 2, then you add 3. Use that idea to find f of 7 and what f of x plus 1 would be. Part B, you should get a number. Part C, you're going to get a thing that still has x's in it. And then think also D about how you would describe the domain and range of that function. If you want to take for all of that, multiply by 2. Okay, so finding f of 7 is 7. 7's and we're replacing the x value, right? So to throw back to our earlier examples, that's a number of hours that you worked or a button that you're choosing, right? What we're going to do is replace x anywhere it shows up with 7. So what does f of 7 look like? Like, how do I write down f of 7? It's 2 times 7 plus 3, right? Which is order of operations stuff a little bit, right? 2 times 7 is 14, plus 3 is 17, right? Everybody agree? Everybody okay with that? Okay. And you can kind of see that this is a function because the only thing 7 is ever going to give me as a result there is 17, right? Because these operations always, only do one thing, right? 2 times 7 plus 3, that's always going to be 17. So we preserve that function relationship. If you can write a thing down like this, then it is a function, sort of like necessarily, right? What about f of x plus 1? Yeah, try like the same approach. Replace where the x was before with x plus 1. Now you want to replace that like it's a whole thing, right? You're replacing one thing with sort of a quantity. So it becomes 2x plus 2 because the first thing that happens to it is it gets multiplied by 2, right? Or if you're replacing, then you distribute that 2 and you get 2x plus 5. Okay, so the thing I want you to be thinking about between now and Thursday is answering this last question, D, how would you describe the domain and range? And then use that to try to think through what's happening in this fourth example. So the fourth example is tied to this graph that's in Desmos that you get from the QR code at the top of the page, but pull that graph up and try to think through. This is kind of like tying it all together, right? This is pulling all of this stuff into to kind of put it all together and figure out everything that's going on. So think through basically the rest of this stuff. For Thursday, and we will pick up right there and then kind of move on and talk some more about like graphing and stuff. All right, y'all have a good day. I will see you on Thursday. Again, if you have any issues with my math lab stuff or anything else I can help with, please let me know.